All right, this example says to sketch a graph of f of x equals arctangent of x. So in order to graph arctangent of x, we should probably figure out, well, what does that mean? Most of you are like, what even is arctangent of x? Depending on the textbook, they might use arctangent. Most of our textbooks use tangent inverse. So these are equivalent, okay, just so you know. So arctangent is tangent inverse. So we're going to graph the inverse of tangent. So in order to graph the inverse, I'm just going to start out by graphing tangent. Okay, so we've talked about tangent. Remember, it looks like this. And there are some asymptotes on tangent. And the period of tangent is pi. So this is the distance of pi. So that makes this asymptote pi over 2. And then this asymptote is negative pi over 2. Okay. And then remember, tangent repeats itself. However, in order to find an inverse, I'm only going to focus on this part, because otherwise, if I did it for the other pieces, it would not be a valid function, okay, because it wouldn't pass the vertical line test. So then I think about my inverse. So in order to graph the inverse, they always are symmetric across the line y equals x. So what this is going to do is flip it, okay, and it will look like cross y equals x, this. And if you aren't sure, you can always graph it on your calculator. Biggest thing, you guys, when you graph this is make sure you're in radian mode, so check your mode. I'm currently in radians, otherwise you can change it under mode. Then we would go y equals, clear out whatever functions we got in here. And then we would go second tangent inverse of x, and we would graph it. And you would be able to check what tangent inverse looks like. It looks like there's some horizontal asymptotes going on here. So I'm going to use my original tangent function to figure out what those are. So if they flip, we now went from vertical asymptotes to horizontal asymptotes. So this one was x equals pi over 2, and then to make it horizontal, it's now y equals pi over 2. And then this one would be y equals negative pi over 2. There we go. And if you are not sure about those, what you could do is you could take and hit trace on your calculator, and you could take it all the way over. Come on, mine is not working very well right now. You could trace this all the way over to the far right side and see what value it gets close to. It wouldn't be exact, so you'd have to remember, okay, what are my pi values? And then you could type them in to figure out like who is close to. And if you take this and your calculator works a little bit better than mine, you should see that gets so close to like 1.57, which is pi over 2, okay? Mine is moving really slow right now. The other thing you guys could do is you could go to your table, and it should be turned to ask. Come on. So you guys should have your table set to ask from 2.2, less than 2.2, you did that, and then I'm gonna go table. And what I could do is, in order to figure out which way it's going, I'm gonna just plug in a super, super large x value. And you guys should see it's 1.5708, okay? And you could just confirm that by typing in some options. So pi divided by 2, 1.57. Okay, so there it is. So those are my asymptotes. So we have our graph sketched right here. This is tangent inverse or arctangent. And now it says find the limit as x approaches infinity of tangent inverse. So I'm looking all the way to the right. So I'm following this, and as this continues to go to the right, what y value will it approach? It will approach pi over 2. And if I go ahead and find my limit as x goes to negative infinity of arctangent, so that means I'm going to look all the way to the left, so I'm following my curve all the way to the left. What's it going to get very close to? My horizontal asymptote, which is negative pi over 2. And that is this example.